Hopefully I don't need to swap displays. We're now going to explore some exponential functions for the rest of the period. Together, we have negative and fractional exponents we need to talk about, and we're going to introduce exponential equations. We're going to talk more about those next time. So, negative and fractional exponents. If I have an expression like 5 to the negative 2, what the negative exponent means is reciprocal. It does not mean put a negative into the answer. So here are two examples. 5 to the negative 2 is reciprocal of 5 is 1/5. So it's 1 over 5 to the positive 2. Now if I said write it with a positive exponent, 1 over 5 to the 2 is done, or 1 over 5 squared. If I said to evaluate, then it would be 1 over 25, because 5 squared is 25. Another example, so that we're clear on this whole reciprocal thing. 3/7 to the negative 2, negative exponent does not mean put a negative sign anywhere. It means flip it, take the reciprocal. So 3/7 flips to 7/3, and 7/3 squared is 49 over 9. Now, when I was teaching this in public school, I go, negative exponent! And the class would say, reciprocal, sir. So the negative exponent means reciprocal. And I just want to go one step further. I actually want to show where this comes from now. Let me add a text box. Home. Text box. And let's get red ink going on there. So let's go insert equation fraction, so you can see how I do this, blah, blah, blah. Let's go here, over. All right, so you can see, well, I'll do it when the slide is done. So you're actually working along with me as I'm doing one of these. Must be super exciting for you. So now you see what goes into this, which is why I usually copy them over. And sometimes I forget to change one of the numbers, because these can be pretty time consuming. Come on, my computer's running a little slow here, which is why I will have a new one pretty soon. Come on. Do-do-do-do. Oh, this is what I want. Now you see exactly why I make these mistakes sometimes. All right, so let's go back to our slideshow. It shows you why I make mistakes every now and then, but it also shows you a really good explanation. So look, 5 to the negative 2 is 1 over 5 to the 2. Remember, a negative exponent, reciprocal, sir. So the reciprocal of 5 is 1 over 5 squared, which is 1 over 25. Or the reciprocal of 3/7, because it's a negative exponent, is 7/3. Again, we only take the reciprocal if it's a negative exponent. And in this case, if I wanted the exact value, it would be 49 over 9. Now, where does this negative exponent stuff come from? Well, let's take a look at this example. X to the third over x to the fifth. So x to the third is xxx, x to the fifth is xxxxx. Now, these three will cancel out, the first three. And that leaves, in the numerator, a 1 and x squared in the bottom, xx. So it's 1 over x squared. But if we do the subtraction, 3 minus 5 is negative 2. So that's why a negative exponent is the reciprocal and has nothing to do with the negative sign. So with that in mind, let's go one at a time. What is 7 to the negative 8 power? So again, I'm not trying to figure out, calculate it. The directions say express it with a positive exponent, so that's all I'm doing. So it's 1 over 7 to the positive 8. You try the next one. So this negative sign here in the exponent doesn't do anything to the number. If the number starts out positive, it stays positive. If it starts out negative, it stays negative. So I get 1 over negative 5 squared. Let's try the next one. In case you can't read it, that's negative 1 to the negative 12th power. A negative exponent, reciprocal, so that'd be 1 over negative 1 to the 12th, positive 12. Every time we apply the negative in the exponent, all it does is make it reciprocal, and then the exponent becomes positive version of itself, or the absolute value of the exponent. Okay, g to the negative 17. Go ahead. Negative exponent, 1 over g to the positive 17. Now, in each of those cases, we saw the negative exponent, and then we wrote the fraction form. Now we're given the fraction form. Let's have you write the negative exponent. Let's try number 13. So that would be 2 to the negative 19, or 10, I'm sorry, 2 to the negative 10. Try number 16. (39) to the negative 1. Number 19. In case you can't tell, that exponent's a 3. X to the negative 3. And number 22, which is 1/8. (8 to the negative 1). Okay? Now, I just want to go over a little bit about what these graphs look like and the differences. So here is y equals 2 to the x. And here's y equals 2 to the negative x. Basically, it's the same graph flipped or reflected over the y-axis. Here's y equals 3 to the x. Well, that's not 3 to the x. I'm sorry. 3 to the negative x is the correct graph. 3 to the x is not the correct graph. I don't know how that got put there. I must have made a mistake. 3 to the x graph looks very much like the 2 to the x graph. Okay? The 3 to the x graph looks very much like the 2 to the x graph. So in each case, it's just the reciprocal of the preceding one. I should say reciprocal. That's harkening back a bit for. It's a reflection over the y-axis. Okay, fractional exponents next. So we've done negative exponents. Now we'll do fractional exponents. With a fractional exponent, basically, the power is in the numerator of the fraction, and the root is in the denominator of the fraction. So it's power over root. And I have this like kind of silly way of remembering this. I picture like, you remember in elementary school kids were in the play, and kids got the most crazy, silly, childish parts. Like some kid would be a tree, and I picture them going up to on the stage, and like the whole tree is a cutout, and they stick their face in a hole somewhere on the upper trunk of the tree, and then they put their arms out where the leaves are, and they can shake their arms. And I can picture the only kid's line being, "The roots of the tree are down, the power is in the leaves. The roots of the tree are down, the power is in the leaves." So, the roots are down, the power is in the leaves. And I always I prefer to write it so that the root is, I do the root first because the roots are easier to compute. So for example, 8 to the 2/3, the roots of the tree are down. It's the third root of 8, and the power is in the top. Power over root, or the power is in the leaves. So an equivalent 8 to the 2/3 is the cube root of 8 squared. Now the cube root of 8 means the number that times itself, and then again is 8, and that's 2, right? Because 2 times 2 times 2 is 8. Then you've got to square it, and you get 2 squared is 4. So 8 to the 2/3 is 4. You could square the 8 first and say, well, what's the cube root of 64? That's also 4. But as numbers get bigger, it's a little bit harder to do. So I like to do the root first when the numbers are small. Of course, these days you could take your calculator and you could do 8, then the caret symbol or the up arrow symbol, which is on the right-hand side, and then in parentheses, 2 divided by 3, and it'll tell you 4. Okay? So with fractional exponents, the root of the tree is down. So like x to the 1 over n is the nth root of x. So like the square root of x is the 1/2 power, the cube root of x is the 1/3 power, the fourth root of x is the 1/4 power, and so on. Or if they give you a fraction with something in the numerator and denominator, it's the root to the power. It doesn't matter which order you put it. Okay, so let's have you try this first one. And just so that you know, 5 to the 1/2, okay, that's what that says. And then 6 to the 4/3 and 2 to the 5/3. Now you're not being asked to evaluate this and figure out what it equals. So you don't want to go on a calculator. You just want to write it in exponent form. So the 1/2 power would be the square root, and I'm emphasizing you don't need to write the 2 out there for square root, but for the purposes of demonstration, I'm showing you this. Square root and then 5 to the 1st, because the power goes in here and the root goes on the outside. So you try the next one with 6 to the 4/3. Okay, so that would be the cube root of 6 to the 4th. Next one is 2 to the 5/3. Okay, so that would be the cube root of 2 to the 5th. All right, now I think you've got the pattern down pat. Let's try numbers 4 through 6. Go ahead. Okay, so for the next one, 9 to the 3/4 would be the 4th root of 9 cubed. Next, 3 to the 3/2 would be the square root of 3 cubed. And the next, 6 to the 1/4 would be the 4th root of 6 to the 1st power. So in each of these problems, numbers 1 through 6, we took a fractional exponent and we wrote it in radical form. Now we're going to do the opposite. We're going to take the radical and write it in exponential form. So here, as I take a look at the number 10, I see that the power of the 10 is 1, and it's the square root. So this is 10 to the 1/2. You try the next one. Okay, this would be, now the power is 3, and the root is the square root. Remember, that's really a 2. So this is 5 to the 3/2, not the 1/2. Let me just correct that. Very hard time saving things. 3. Okay, let's go back to See how I make my careless mistakes. And two more. There we go. So 5 to the 3/2. Now, here we got another one. That's the 4th root, in case you can't see it, of 3. Remember, if we don't write a power on the 3, it is 1. So that's 3 to the 1/4. Why it says 4 to the 1/4, I do not know. That I won't correct because it should be 3. I will correct that a little bit later. Okay, let's check this out here. Next up, the 4th root of 2 cubed. The 4th root of 2 cubed. So that's 2 to the 3/4. And the last one is the 4th root of 5 to the 5th. The 4th root of 5 to the 5th. And that would be 5 to the 5/4. Okay. Next up, we want to express these in exponent forms. So I'll go through these with you step by step. This first one is the cube root of 15 to the 4th. The cube root of 15 to the 4th. Go ahead. The roots of the tree are down. The power is in the leaves. So that's 15 to the 4/3. Let's try number 2. That's the square root of 13 to the 3rd. So that would be 13 to the 3/2. Remember, with a square root, we don't bother writing the 2 out there, but there really is a 2. Next one up, the cube root of 2c to the 4th. The cube root of 2c to the 4th. So that'd be 2c to the 4/3 power. And then over here, the 4th root of 15 to the 6th. The 4th root of 15 to the 6th. Okay, so that would be 15 to the 6/4 power. Okay, so what we've discussed so far is a negative exponent, how to deal with that. Fractional exponents, how to deal with that. Negative exponent, negative exponent. Reciprocal, sir. Fractional exponents, the roots of the tree are down. The power is in the leaves. Last but not least, for new stuff, would be, this is a hint as to what is coming. This is our next lesson. Exponential equations, and we can have the variable in the exponent, or we can have the variable in the place of the regular number. And the next lesson we will deal with variables in the place of the regular number, and after that, the next week we deal with logarithms, and we'll do some with variable in the exponent tomorrow, and then we'll do a lot of them when we get to logarithms. Okay. So x to the 2/3 plus 5 is equal to 9. So look, these things, they're just like regular equations. Negative 5 to both sides, x to the 2/3 is 4. So here's the problem. The problem is we don't want to know what x to the 2/3 is. We want to know what x to the 1 is. But if I multiply 2/3 by the reciprocal, which only happens when I raise a power to a power, I can get it. So I'm always do the same thing to both sides so that the equation stays balanced. I'm going to raise both sides to the 3/2 power, and that's what I do here, raising to the 3/2. Notice the reciprocal of 2/3. I raise to the 3/2. 2/3 times 3/2 is 1, so I get x to the 1. And on the other side, the square root of 4 is 2, to the 3rd power is 8. Okay? So just remember, isolate that x, and then you're going to raise to the reciprocal power, both sides. Isolate the variable, raise to the reciprocal power. When the variable is not in the exponent, it's a regular number. Here's another example. Add 1 to both sides. Divide by 2. 32 divided by 2 is 16. This says x to the 4/3. The reciprocal of 4/3 is 3/4. Make sure you do it to both sides. X to the 4/3 to the 3/4. 4/3 times 3/4 is 1, so that's x to the 1. And then the 4th root of 16 is 2, cubed is also 8. That's just pure coincidence. Okay, so I didn't put this in the happy recap, but I just want to remind you one more time. With negative exponents, negative exponent, reciprocal, sir. With fractional exponents, the roots of the tree are down, the power is in the leaves. And then some past things to remember here. Composition of functions means that you take the first function, you get an output, and that becomes the input of the second function. What's the difference between a relation and a function? In a function, every input can only have one output. You can't have two different outputs from an input, and every element of the domain has to have an output. Next, what important matters do you need to remember when solving radical equations? Isolate and square. As far as a peek into the future, when we do exponential equations and we have a variable like x to the 2/3, then we have to remember to do the inverse of 2/3, which would be 3/2. Okay, and if you remember that a radical equation or a radical is the 1/2 power, and then we're squaring it, you can see the flip there too, right? 1/2, 2/1. So we just had one that was 3/4, and then it became 4/3. Okay, that, folks, takes us through lesson number 19. 3 more brand new lessons to go, 3 and only 3. Then we have a test. Then we do a week of final exam review. Then we have the final, and the course is done. We are getting so close to the end. Have a